every aircraft begins long before metal meets machine.
Design requirements are translated into digital structure. Virtual testing validates strength and durability. Tooling defines how precision is achieved on the floor. Digital paths become physical accuracy. Dimensions are verified before production use.
Looks good. All green across the board?
Yeah, we can approve this.
Tooling preparation ensures repeatability. Materials and tooling are synchronized across suppliers. Approved tooling enters production flow. Airframe fabrication begins with structure. Composite plies are cut to precise geometry. Layer orientation controls strength and stiffness. Curing bonds the structure under heat and pressure. Cured components are trimmed to final dimensions. Metal structures reinforce critical load paths. Geometry is verified before integration. Airframe sections are cleared for system integration.
Primary structure is complete.
Dynamic systems convert power into controlled flight. Rotor blades combine strength, balance, and aerodynamic precision. The hub transfers load between blades and transmission. Transmission components are machined to exact tolerances. Sealed assemblies protect critical systems.
Landing gear absorbs loads during ground operations.
Load testing confirms structural performance. Dynamic systems are prepared for integration.
These systems now move to the airframe.
Mechanical foundations are complete.
Systems integration brings the airframe to life. Power plants are installed as complete, tested units. Mounting accuracy is critical to alignment. Twin engines are installed to identical standards. Fuel systems are routed for protection and accessibility. Integrity checks confirm leak-free installation. Hydraulic systems are verified independently. Thermal management components complete the bay.
Mechanical and safety systems are interconnected.
Check the clearance on P3 next to the hydraulic line.
Reading 0.25 inches, well within tolerance.
Confirmed. Routing looks good here.
Fit checks precede final closeout. power and mechanical integration is complete.
Next, the aircraft's electronic systems come online.
Electrical integration brings systems together. Routing follows defined paths for protection and serviceability.
Avionics units are mounted on vibration-isolated structures.
Human-machine interfaces are verified for fit and feel.
Power distribution is organized and protected.
Interfaces are secured to withstand vibration. Initial power is applied under controlled conditions.
System communication is verified.
Lighting and ergonomics are evaluated.
Systems are closed out after verification.
Electrical integration is complete. Ready for final assembly and testing. Final assembly brings every system together. Critical joints are secured to exact specifications. Systems are verified before power is applied.
Initial power on confirms system communication.
See the spike here on the schematic? That explains the fluctuation.
What about the auxiliary power levels?
Ground tests validate mechanical performance.
Bring it down another 5 centimeters, watch the clearance.
Copy that. Coming down slowly, we have a solid lock.
Vibration levels are carefully measured. Surface preparation precedes final coating. Coatings protect and preserve the airframe. Final inspection confirms readiness.
The alignment on this panel seems acceptable.
Agreed. Moving to the checklist, Section 4, External Surfaces.
Manufacturing gives way to service.